Here I'm going to show you how to find the number of roots, which is also the number of x-intercepts or the zeros of a quadratic function. The approach you take will depend on which form the equation is written in. In these three examples that I have on the screen, they're all written in vertex form. So in this format, where basically I can look at it and I could tell what the vertex is. And using my vertex as the hk along with the a value, which when it's positive tells me the graph opens up, and when the a value is negative tells me it opens down. Putting all of this together, I can quickly find out the number of x-intercepts. So let's look at how the first one works. I have a vertex form. Looking at the equation, I have a -1 here. So I know my vertex will have an axis of symmetry of x is equal to +1, so 1. And the y value of my vertex is at 5. So I'm going to plot the vertex at that point, 1, 5. And looking at the equation, we have an a value of 3. Because this a value is positive, that means my graph opens up. So positive, it's a smiley face. And so I go to this point, I open it up, and now I've got to ask myself, how many times will this graph cross the x-axis? Don't worry about the y-axis, those are not the zeros. I want to know how often the graph is going to cross right here on the x-axis. And you can see from the graph that there is never such a point. So we say that there are no roots. There's none. No x-intercepts, no roots, no zeros for this. Let's look at example B. Here in the brackets, I have x plus 4. So that means my axis of symmetry is that x is equal to -4. So -4 for the x, -8 for the y. So I plot my vertex at -4, -8, -4 on the x, -8 on the y. And this graph will also open up because of the positive a value. Positive a, graph opens up. So this is a rough sketch of this parabola. And ask yourself, how many times will this graph cross the x-axis? You can imagine if I continue drawing these arrows, there would be 2 x-intercept points. The graph will cross the x-axis at 2 points. So we have 2 roots, 2 x-intercepts, 2 zeros. Let's look at example C. This one you might think maybe it doesn't look like a vertex form. You could certainly make the argument that this is a standard form, but it's also a vertex form if you just rewrite it as x minus 0 squared plus 1. If I don't have x plus or minus a number before it's squared, like in these two examples, then just assume it's -0. Your vertex then is going to be at 0, 1. And then if you plot the vertex and use your a value for the direction of opening, you'll be able to see how many zeros there are. This time my a value, there's a negative there. Without the number, my a value is -1. It's a negative, so the graph will open down. So open it down, and you can see that this graph will also have 2 x-intercept points. Next, we're going to do 2 examples where the equations are written in factored form. And this is probably the easiest way to tell how many x-intercepts you have. After all, the factor form was designed to easily get that information. So I'm going to look at the first equation as 2 copies of x minus 6. And if I want to find my x-intercepts, I just set each of these brackets equal to 0. and they're both going to tell me that x is equal to 6. So I have one x-intercept point. There's a single root, there's a single zero for this function, and it happens to be the value 6. Question B. I have it in factored form. I can set each factor equal to 0 to find out my x-intercepts. Remember, you can only do this kind of approach with factored form. And a factored form is when the two are multiplied together. 2x equals 0. I can divide both sides by 2. X is equal to 0. X plus 5 equals 0. I can move the 5 over. It becomes a negative 5. And there you see it. We have two roots, two x-intercepts, two zeros. That's how we do it in factored form. I can't think of an example of a factored form that doesn't have any zeros. In fact, there is no such thing, so you don't have to worry about that case. But if your quadratic equation is in factored form, you can easily figure these out. So factored form, you should find out what the zeros are. Vertex form, you should graph, and you will see how many zeros there are. And the last format is when you have the standard form. So if it's a standard form with y equals ax squared plus bx plus c, then there's a different approach for these. It's the discriminant. Use the discriminant. The discriminant is d is equal to b squared minus 4ac. And so this is going to tell you how many zeros there are. If this answer ends up being positive, then you will have two roots. If this answer ends up being equal to 0, you'll have one root. And if this answer ends up being negative, you're going to have no roots. These are the three possible cases with quadratics. So let's look at all three of these. And because they're all in standard form, I'm going to use the discriminant. First one, my a value is 2, my b value is negative 5, and my c value is 1. I'm being asked to find how many x-intercepts there are, and it's in standard form, so I calculate the discriminant. Negative 5 squared minus 4 times 2 times 1. So I get 17, which is greater than 0. If you're doing this on a test, please say that since d is greater than 0, your teacher will want to see this part. Since d is greater than 0, there are two roots. There we go. Question B. A, the number multiplied by x squared, if it's just a negative, it's a negative 1. B will be the 6, C will be the negative 9. Put them through the discriminant, but please make sure that you only use the discriminant when it's in standard form. I see this quite often. Students want to do the discriminant for a factored form or a vertex form, but that would be a waste of time. For those two other forms, refer to the examples we've done earlier. Okay, standard form, we can use discriminant. And let's see what answer I get. So 6 squared minus 4 times the a times the c, which is negative 9. I get 36 minus 36, which is 0. Okay, so now we can say since d is equal to 0, there is one root. That's how you show your work. Okay, and one more example. We're going to look at example C. Example C, my a value is 3, my b value is negative 1, my c value is equal to 2. Calculate the discriminant. B squared minus 4 times a times c. Simplify, 1 minus 24 is negative 23. Now I have a discriminant that's a negative. Again, I want to say that since D is less than 0, there are no zeros. You want to communicate to your teacher what you are doing. So no zeros, no roots, no x-intercepts. Okay, hopefully you learned how to find the number of zeros with this video. Thank you for watching.